This video is part one of linear equations. We're going to be learning about graphing lines and the characteristics of lines. So we're going to start off with what is possibly a review for you. Some of you may have seen some of this, but if not, no worries, we're going to go over it. What you're looking at here is a coordinate plane. A coordinate plane is made up of two axes that are perpendicular to one another. The x-axis is horizontal, the y-axis is vertical, their intersection point is the origin. The origin separates each of the axes into positive and negative numbers. For the x-axis, the positives are on the right and the negatives are on the left. For the y, the positives are on the top and the negatives are on the bottom. Oops. Sorry about that. So it's a surface where we create graphs. And again, we have the x-axis, the y-axis, and the origin. You can pause the video if you want to write down those definitions. I'm going to go ahead and move on. So in order to graph lines or other things on a graph, not all shapes on a graph are lines, but we're going to be focusing on lines. But anyway, when we plot points, we usually connect those points to form some sort of graph, such as a line or a curve. So let's start with the basics on how to plot a point. So an ordered pair is an address of a point on the coordinate plane. It has two numbers separated by a comma. The first number is your x-coordinate, and the second number is your y-coordinate. We always begin in the origin if you're graphing a point, and we move right or left on the x-axis to locate the x-coordinate. If it's positive, go right. If it's negative, go left. And from that coordinate, that place on the graph, you'll count up or down, depending on the sign, to find the y-coordinate. So to plot 3, 1, here's the graph. We start at the origin, start here, and move right 1, 2, 3 spaces to 3 because the x-coordinate is 3. And then from 3, we move up 1 because 1, positive 1 was the y-coordinate, and then that is where we put our actual point. So 3, up 1. If it had been negative 3, positive 1, we would have went left 3 and up 1. If it had been negative 3, negative 1, we would have gone left 3 and down 1. Positive 3, negative 1 would be right 3 and down 1. Okay? So you guys try. We're going to plot the following points on the coordinate plane. We've got 5, 2, 3, negative 4, negative 1, 1, 0, 3, negative 4, 2, negative 4, negative 2, and 0, 0. So pause the video and try to plot these points. Okay? Hopefully everybody tried to plot these. Let's check your answers. So for 5, 2, we move right from the origin, you move right 5 and up 2. For 3, negative 4, we move right 3 and down 4. Always do the x-coordinate first. That's the first one. Then we have negative 1, positive 1. So x-coordinate is negative 1. On the x-axis, negative 1. Up, positive 1. 0, 3. 0 is the x-coordinate. So we stay where we are, and then we just move up 3 and put the point. Negative 4, negative 2. So we move left 4 on the x, down 2 on the y, and then 0, 0 is the address of the origin. All right. Next, we want to talk about quadrants. So the x and y axis separate the coordinate plane into 4 quadrants. So just 4 areas. So this top part is quadrant 1. We're going to move counterclockwise. This is quadrant 2, quadrant 3, quadrant 4. Now you'll notice I have parentheses with signs separated by commas. This kind of represents the signs of ordered pairs, so that you would see by looking at the ordered pair signs, you can tell what quadrant it falls in. So all the points in quadrant 1 have positive x's and positive y's because you move right and you move up. All quadrant 2 points have negative x's because you move left and positive y's because you move up. And then quadrant 3, they're both negative because you move left and you move down for the x and the y. And then for quadrant 4, it's positive x's and negative y's. So you can, if it asks you what quadrant a point is in, you can do it one of two ways. You can look at the signs and use this little graphic organizer here to help you, or diagram. And the other way to do it is to actually plot the point and see where it falls. So here you have 4 points. Why don't you pause the video again and determine the quadrant in which each point is located. Okay, hopefully everybody had a chance to work this as an example. Let's check our answers. -5, +5, we move left 5 and up 5. And there's our point. So that is quadrant 2. 3, 2, move right and up 2, and that's quadrant 1. 1.5, -4, we move right 1.5 down 4, that's quadrant 4. And then -4, -1 would be in quadrant 3. So there are all of those written out. All right, moving on to actual equations. So take a look at an equation like y equals 3x plus 1. Excuse me, this equation gives a relationship between x and y. For every x, there's going to be a corresponding y, and those would form ordered pairs. So to graph, what we do is we choose a few x's and we find the corresponding y's. You can choose any x's that you want. I have chosen 0, 1, 2, and 3. You do not have to choose these same numbers. You can choose different x's. Actually, usually I choose a couple negatives, a couple positives, and 0, just to have it balanced. But basically, you can choose anything that you want. I usually try to keep the numbers small so that the x's will be at least close to the origin. So what we're going to do is we are going to calculate the y for each one of these points. So each one of these x's. So for x equals 0, I'm going to put in 0. So y equals 3 times 0 plus 1. 3 times 0 is 0. 0 plus 1 is 1. So that's the ordered pair 0, 1. So we can plot that and kind of see. Oops. See where I've got that there. Okay, so now we're going to do the same thing, but we're going to do it with 1. So y equals 3 times 1 plus 1. And 3 times 1 is 3. 3 plus 1 is 4. So that's the ordered pair 1, 4. So we're going to go right 1 from the origin. Right 1 and up 1, 2, 3, 4. All right. Now we'll do 2. Y equals 3 times 2 plus 1. That would be 6 plus 1, which is 7. So now we have the point 2, 7. So we're going to go right 1, 2, and up 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And we're going to put a point. Points are not easy to draw with a mouse, by the way. And then last, we're going to put in 3 for x. 3 times 3 plus 1, which would be 9 plus 1, and we get 10. So that is the ordered pair 3, 10. So we're going to go right 1, 2, 3, and up 10. This is 7, 8, 9, 10. Right there. And you can see that those points line up nicely. Now we're going to draw a line. Now bear with me because I'm drawing this on a computer screen. It's probably not going to be the straightest. It's not so bad. Alright, and then we just connect the points and form a line. This works much better if you have a straight edge such as a ruler. But there you go. So what you want to do when you're graphing a line, there are actually a couple different ways to do it, but one way is to form a table like we did here. You're going to pick 4 to 5 X's. You actually need a minimum of 2 or more. I usually do about 5, and I do that because if you have 2 points, oops, I've just messed up my line. If you have 2 points, let me erase that. If you have 2 points, they will form a line, but what if one of the points are wrong? So you can do 3 points, and if those don't line up, you know that one of them is wrong, but which one? So that's why I usually do 4 or 5, just so it's easier to see if I get something wrong, which one would be wrong. Alright, moving on. Why don't you pause the video and you try y equals negative 2x minus 5, and I've given you 5 x's to substitute in for x, find the corresponding y's, and graph. Okay, as you can see, I've worked this out for us. I've substituted each of the x's into the x and solved for y. And you'll see I've got negative 1, 1, negative 5, negative 7, negative 9. You can look down here to see the work. And I've plotted each one, negative 2, negative 1, negative 3, positive 1, 0, negative 5, 1, negative 7, 2, negative 9. And then we connected the points because they formed a line. Okay, we're going to stop this video here, and we're going to pick up with part 2 with slope.